Hello everyone, my name is Rita Sanchez and my lesson will be over the introduction to the Pauling scale and what it says about the elements. Before I begin this lesson, I would like to show an application problem that can be solved after this lesson is over. Using the Pauling values, determine whether the following bond between carbon and oxygen is A covalent, B polar covalent, C partial ionic, or D ionic. You will be able to solve this with the values on the left. So some of our learning goals are going to be 1. Understand the electronegativity, 2. Define Pauling scale and its purpose, 3. Determine when the Pauling scale should be used, and lastly, apply the Pauling scale to chemistry problems. So who even invented the Pauling scale? Linus Pauling, shown to the left, was the first scientist to describe electronegativity. He described electronegativity as the power of an atom in a molecule to attract electrons to itself. From this, then he created the Pauling scale, which measured different electronegativities in each atom. As he was arranging the Pauling values, he found that the main properties to decide the electronegativity of an atom were the atomic number and the atomic radius. He also found that high electronegativity meant that the atom attracted more electrons, and low electronegativity meant that the atom gave away electrons. Okay, so the Pauling scale measures the electronegativity of each element. It ranges from francium, the least electronegative, with a value of 0.7, to fluorine, the most electronegative, with a value of 4.0. If we look at the periodic table shown below, we can observe that most metals have a value less than 1.5, and most nonmetals have an electronegative value greater than 2.0. We can also observe that in the periodic table, noble gases like helium, neon, argon, and krypton are empty, and that is because they don't form bonds. I also wanted to point out that the arrows going upward and to the right around the periodic table are just to show that electronegativity is increasing. Okay, so now the purpose of the Pauling scale is that it helps us determine the polarity of a bond, position of an element, and the dipole moment of a molecule. These two images below show that depending on the electronegativity difference, it will give you a different bond type. So let's say, for example, the electronegativity difference is less than 0.5, it would be a covalent bond, and so on and so forth. Okay, so now let's answer some questions using the Pauling scale. Number 1, order the following elements of increasing electronegativity. We have fluorine, lithium, carbon, and oxygen. Fluorine has a value of 3.98, which is the highest, so it's going to go last. Lithium has a value of 0.98, so it's going to be the least electronegative, so it's going to be first. And then carbon has a value of 2.55, so it's after lithium. And then oxygen has a value of 3.44, so it's going to be in between carbon and fluorine. So now our order is going to be lithium, carbon, oxygen, and fluorine. Now going to number 2, which is the same one I put in the second slide, saying that you will be able to solve towards the end of the lesson. Using the Pauling scale values, determine whether the following bond between carbon and oxygen is A covalent, B polar covalent, C partial ionic, or D ionic. So if we look at our periodic table and see carbon and oxygen, we see that oxygen has a value of 3.44 and carbon has a value of 2.55. So we're only going to subtract 3.44 minus 2.55 and our value is going to be 0.89. Then from this, we determine what bond it is. So 0.89 falls in between 0.5 and 1.5. So it's going to be polar covalent bond. So that's our answer, B. So now, just to recap on this lesson, the Pauling scale measures the electronegativity of each atom, and it can be used to determine the placing and order of elements in the periodic table. This also helps predict the nature of chemical bonds, and it helps us understand a reaction depending on the bonds made. That's all for today. Thank you.